So here's a very interesting problem on projectile motion. So it says in this figure here, the one that you are seeing on my right side, a rescue plane flies at 198 kilometers per hour, which is equivalent to 55 meters per second, and a constant height of 500 meters towards a point directed over, also directly over a victim. So this is a victim there. Where a rescue capsule is to land, what should be the angle theta, this angle here, or phi, so rather, of the pilot's line of sight to the victim when the capsule release is made? So we have some key ideas here. Once released, the capsule is a projectile. Keep that in mind. So the horizontal and the vertical motions can be considered separate. Remember, the horizontal motion and the vertical motion under projectile motion are independent on each other. That means they don't have effect on one another. So how do we find theta? Now, before I even go anywhere, this is a cut triangle, so this is a cut triangle of this nature. Where this is H and this is X, and the angle we're looking for is that one. Now, the angle is opposite to this one, so this is our opposite, and this one becomes our adjacent. Which trig ratio relates opposite and adjacent? Tangent. So we're saying tangent tan phi is equal to opposite, which is X, over H. So, to find the angle theta, or why do I keep saying theta? Phi, this will be equal to tan inverse of X over H. That's all. So we need to find X because there's already X here. So we need to find this distance for us to be able to work out this problem. So how can we find this distance? Take note, we are going to use the range equation. We know that range is given by just distance multiplied by what? Time. Oh, velocity multiplied by time. But in this case, our velocity is u sine theta. Okay? We multiply that by what? T. That is very important. Wait, what's happening? Cosine theta, sorry. But take note, this is our initial velocity. So let's say u naught. Cosine. Even the angle itself, it will be with a naught there. Then we multiply by t. But what is range? Anytime here range, it means there's just a change in displacement. So we are calling it x minus x naught. So the x here is the final, this one x naught is the initial. So this is the equation we need to keep in mind. And for us to find x here, we need to find t. How can we find t? All right, t is just the time of flight. But how can we find it? How can we find it? Take note, we are now going to consider the vertical motion. Under the vertical motion, we are saying change in y. Okay, I think you know this equation. U sine that with a naught again with a t minus. You recall this equation, isn't it? One of the laws of motion. So one of the equations of motion, I've just replaced velocity with this because it is in the y direction. You get the concept, so we get the sine component of that. Use theta. Let's use theta there. Yes. Use theta. That angle there is quite different from theta. Okay. I think if you see it from here, there's a theta here. So that's the angle that we're using for now. We're not using that one there. Taking no time. Okay. So now we need to find t from here. Final distance, since it's dropping somewhere there, so the final distance is just 0. That will be 0 minus 500 as the height. I think you can see there 500 multiplied by 55 sine. Now initial angle is 0 here, degrees, minus half. Acceleration is 9.8. Then you put t squared there. Oh, there's a t here. This will give us 0. Everything is equal to. This gives us 0, so we get negative 500 is equal to negative half 9.8 t squared. So can you confirm with me that if I divide 9.8 by 2, then I divide it this side, you are getting something like 102.040863. That's what I'm getting. Then I'm going to do the square root. Don't round off until the final answer, please. So t is equal to 10.1 seconds. So this is the time we need. Now that we know the time, we can come here and find x. 0 cos theta and what? T there. So x here, again here is also 0 minus, sorry, here just x, this is initial, here is 0. This is 55 cos 0 degrees, because we are here. So the angle there is just 0, and the time is 10.1. So if I multiply 10.1 by 55, then cos 0, it's just giving me, sorry, cos 0 is 1, we know that. So 55 multiplied by 10.1. Okay, so it's giving me 5.5 meters. So this is the displacement in the x. We found the range, right? Now next is find the phi now. Phi is tangent of x over h, which will be equal to tangent inverse of 5 over, what is y? 500. So it's like that. So we divide that by 500, then we find the inverse of that. So phi is giving me 48.00 degrees. I've just rounded it off, but there should be a 0.1 here. Yeah, there is 0099, so we get it like that. Okay, so yeah, perfect. All right.